Hello everyone, this is Tumala Jaikant. Currently I'm pursuing my BTech in the stream of Aeronautical Engineering from Belar Institute of Technology. Recently I have interned from Emertxe technologies based on embedded systems where the project is based on car black box simulation. So in this video I would like to present about the car black box simulation, what the code I've written and implemented in the project in the period of my internship period. So here comes the things what I've learned from this project or the internship. The internship is mainly based of the period of total 4 weeks, where in the first week it was a great learning of basics of C programming, where I got to learn the normal basics of pointers, C, recursions, strings, arrays, and some of the other basics, and to write the simple codes, etc. And in the from the second week, I got to learn some of the project aim and its design requirements and introduction to various peripherals. And third, fourth week, writing the different peripheral codes, building the X files, and project integration and testing. And finally, at the final week of this workshop. So these are the things which I have learned from this internship, where it was a good learning. And we're coming to the contents which I'm going to present in this video is what is car black box, which actually I've done in the internship as a project as car black box, and the project requirements, what are the things, what are the software requirements which required to install to run this car black box project and execute it, and what is meant by embedded system, where this project and the internship is mainly based on the embedded systems, and what are the microcontroller and microprocessor, introduction to different peripherals used in the project, and finally the project implementation, the demo which I'm going to present in this video. So yeah, what is car black box? The concept of the car black box is similar to the flight black box concept, where it is mainly used to store or record the data of different events of the where vehicle condition, where if these boxes are mainly used to get the data of the uncertain things occurs to the vehicles or some other accident kind of things. So we get an idea about how these accidents have gone prone. We get an idea, or we get a reason to find at which state or which condition these uh, vehicle got occurred to the uh, uncertain condition or some other accident. So we get on data. It also monitors the vehicle current condition and event on the display of the LCD. It has an LCD display, so it all records the data. It displays on the LCD display. It shows all the events, speed, and some other things, timer, etc. things, temperature, everything by using the different peripherals and sensors. It is a low-cost system which provides solution to existing automotive control systems, and I2C integrated inter-circuit is the common peripheral found on microcontrollers widely used onboard communications. So yeah, what is the project requirements? In this project, we require to install some of both softwares. One of the major software is PiximLab board, where it has a board consisting of a microcontroller as per our requirement, and it has a display of different consisting of different peripherals on it. And we need another software known as MPLab XIDE, which is known as Integrated Development Environment. It is expandable and high configurable software, which is used for programming and offers powerful design tools. And it supports the micro project management, editing, debugging, and programming of microchip 8-bit, 16-bit, and 32-bit PIC microcontrollers. So, whereas the PiximLab board is something which is a real-time emulator for the development boards with integrated to MPLab XID. It supports some Pixim microcontrollers and some AVR microcontrollers. So this is about the requirements of the project, where we need to install PiximLab board software, and another one is MPLab XID, which is creates the environment to write the codes. So what does mean by embedded systems? So we get a basic definition, where We understand that any combination of hardware and software which is integrated to do a specific task can be called as an embedded system. It categorizes as standalone, real-time network and mobile uh, kind of systems, whereas in the real-time aspects are again classified as hard real-time, firm real-time, soft real-time. Whereas what I mean by hard real-time, where it should meet its deadline, otherwise it is a right life critical situation or position application. So, for example, for this hard real-time is air balloon, not air balloon exactly, it's an airbag which we use in the cars. So it is a life critical at the correct time. If these airbags doesn't work, then obviously it is a life critical position, right? So that's why it is known as hard real time, and it have to meet its deadline before its deadline. So this is the hard real time category, and firm real time category is almost similar to the hard real time but different in properties, whereas soft real time it doesn't make any difference even if it doesn't meet its deadline, so it can have a tolerance in meeting its deadline. So yeah, this is the soft real time, and these are the different categories of embedded systems. And examples of embedded systems are micro oven, TV, washing machine, rover, missiles, rotors, etc. So these are the different examples of embedded systems. And coming to the microcontroller and microprocessor, where it means microcontroller and microprocessors are different ways of organizing and optimizing a computing system based on CPU, while a microcontroller puts the CPU and all peripherals onto the same chip. A microprocessor houses a more powerful CPU on a single chip that connects to external peripherals. In simple word, we can use a term as CPU, where it just these controller or processor controls. It acts as a processing unit or CPU. So choosing a better microcontroller depends upon the following uh, aspects, which is showing on screen. That is application as per our project suitability, project requirement, and project application. We choose the microcontrollers depending upon the performance, as per our budget, price, availability of tools, special capabilities, etc. These are the things or the aspects which we have to keep in mind and choose the better suitable microcontroller or microprocessor as per our requirement. So yeah, here we can see here, first one is microcontroller. The main difference we can see out here, all components will be in the same chip as shown in the figure. See the timer, ports, rom, CPU, everything is interly assembled here, and it is less flexible and less design complexity for the microcontroller. And in microprocessor we can see here there are the assembly is separately done here. All components are assembled separately, more flexible, more design complexity. Microcontrollers used in our project. So we use a PIC16 F877A microcontroller as per our clear black box project, which is suitable and convenience for our requirement. So these PIC16 microcontroller has these peripherals connected in a typical I2C bus communication, where it's connected with LEDs, buzzer, digital keypad, SSDs, matrix keypad, CLCD, ADC, I2C, GPU, temperature sensor, analog digital converter, RTC means real time clock, ROM. So these are controlled by the microcontroller of PIC16 F877A, which we have used in the PICSIM lab board. So we can see it in the later slide. So yeah, used and learned peripherals for the project. We used and learned different types of PICSIM lab board peripherals, which is mainly used for our project implementation and integration of all codes. So what are these peripherals? So we can see here, this is the PICSIM lab board. So the board is consisting of all different peripherals. We can see it is a PICGenius lab, PICSIM lab board, and the microcontroller. Here we can see the microcontroller here. This is the microcontroller. The used microcontroller is PIC16 F877A, and the peripherals are, these are the potentiometer, these are the tactile switches, digital keypad, LEDs, and this is the CLCD, the main important peripheral of the project of our of our car black box project. So this is, here we can see heater, buzzer, everything. These are the peripherals of this of this Pixim board. So uh, in fact, see, here we can see the EEPROM. Here you can see the real-time clock RTC, uh, which is uh, responsible for the time of real-time time. So yeah, in these peripherals we use some of the peripherals as per our requirement of the project. So yeah, we continue. So yeah, the peripherals we use in the project is mainly CLCD for the display purpose, RTC for the real-time clock, ADC analog to digital converter for the potentiometer switch, tactile switches for digital keypad, internal EEPROM for digital data storage, LEDs and timer sources for interruption and some other things. Coming to the next part, we'll get a brief discussion or brief idea about these peripherals. Where what is CLCD? CLCD is a character liquid crystal display. In Pixim Lab, there are two types of display available, where it is 16 into 2 display and 16 into 4 display, where we get two rows in with 16 lines, 16 digits we can store in this display. Here we have a 4 rows display. It is most commonly used display to show the interface and event recordings. It is mainly used to display the SI character and some special characters. It has two types of communication modes. One is 4-bit mode and another is 8-bit mode. So about this is about CLCD. And what is tactile switch? Digital keypad. This switch is mainly used to select the mode of operation and to enter the required gear events of the project. It is a combi switches under the digital keypad. This switch will produce a bouncing effect when a switch is pressed. It is a switch whose operation is perceptible by touch. So here we can see the tactile switch, a single individual tactile switch where it has a metal plate inside and a terminals positive and negative cathode anode. This is the typical diagram of the switch, and in these again the circuit is characterized with two types of resistor circuit. One is pull down and another one is pull up resistor circuit. The main difference is in pull down resistor circuit, here we can see that in the upside the switch, when the switch is released in the open, then it is the open circuit, and here the closed circuit is towards the ground, so the voltage directly goes to the ground, passing through the R1 resistor. So that's why we call it as pull down resistor. And when the switch is pressed, it connects both here, and it gets a closed circuit, so the voltage passes towards the upside VDD. And in pull up resistor, uh, it is quite opposite to the pull down resistor, where the switch, when it is pressed, the voltage comes to the ground, and when it is open, it's open circuit, and where is the close here, so the voltage goes to the upward. So that's why pull up resistor, it's known as pull up resistor. So that's the main difference behind these two resistor circuits. So what is RTC? RTC is a real-time clock provided to the microcontroller of inter-integrated circuit. It consists of separate battery backup. The power consumption is low. It has a bus feature of communication. So it is responsible for the real-time clock. And ADC is known as analog digital converter, has shown before in the Pixim lab board. It is mainly used for the peripheral of potentiometer for speed control, where it converts the analog input to the output of digital converter. It is the most commonly used in microcontrollers. There are different types of ADCs known as flash ADC, pipe aligned ADC, SAR, and dual scope. And this is the diagram we can see here with the different frequencies of voltage and time. So yeah, what is internal EEPROM? This is another peripheral where mostly used in every embedded system. The size and component memory of storage depends upon the requirement. Modern controller has built-in data storage, where these are again categorized as EEPROM and data flash, etc. It is the storage where the project events can be stored and recorded logs. Um, so what is timer? It's another important peripheral of the project, where timer is an important application in any embedded system which has default peripheral which maintains the timing of any operation in sync with a system clock or an external clock. It has an ability like measuring time and generating delays. Timer is a software designed to count the time intervals between the events. Resolution is also called register width 8 or 16 bit. Tick is referred as the change from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting, is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar, 1:1 or 1:. So these are the things or the terms which comes under the coding when we implement it. So these are the terms which we have learned in the internship. What is the timer, resolution? So everything can be understood when we go deep inside the codes and implement it. So these are the terms in the timer. And coming to the project demo, so we'll see the project demo here. We'll open the pixel board. So this is the main peripheral and has shown here the peripherals we use: EEPROM, microcontroller, reset button, RTC. Here the battery of RTC, separate battery, and these are the switches: 1, 2, 3, third switch, fourth switch, fifth switch, and sixth switches. These are the switches, tactile switches we are going to use in the project, car black box project, and these are known as digital keypad for the source of writing the code. And here uh, what else is the buzzer, heater. These are some other peripheral, but as per our project we need up to these peripherals. So before implementing the project, firstly we have to write the code. So we need MPLAB. This is the MPLAB X IDE environment, so where it creates an environment to write our code and build the program. So here we can see the main C file, main C. So we write the code, we initialize, we start the code, we give the indexing, gear character, static void int configuration. This is the initialization of CLCD module, I2C module, digital keypad, ADC. This is the initialization, and giving we are giving assigning some of the values on and off dashboard uh, as per our requirement. And this is the password we gave here, 2424 for the password for the opening of the dashboard, entering into the dashboard. So while these are the instructions we use for loops and some other things, some of the stuff we used here, and for every important headings we have uh, definition of the program inside here. We can see here, as per the definition the code runs and executes the complete output. So here is the all definition of program. And we have the main head files. So as per the C file, C main, we also have the H file, header files. In the same way we have main H and main C. These are the header files. So yeah, before implementing it, we just have to build here. So here is the build project, so we have to press the button, then the project is going to build. So it takes a bit time. Mm, takes bit time. Wait a second. So yeah, build is successful. So we have uh, built our code or the program successfully. So here is the loading code path, which if we don't know where the location of our build x file, so we can follow the instruction as per given in the path location. So we have to go to the pixel board, and we have here we can see the option file, load hex file. So we have to load it here. So here is my car black box production hex file. This has, we have to select it and we have to open it. So here we can see here the DCLCD is displaying the time in the minute, in the hours, minutes and seconds, and here the event is on speed. Here we can see here. So what we do is we give increase the speed. So it is going on increasing constantly the speed when we are regulating the potentiometer. So we are only restricted up to 99. After 99 it comes into 0 and starts from the initial of 1. So we, as per our code, we have instructed up to 99 the speed. So what we do is, from here which one, we click for the collision event. So we can see here the event is changing. And for the RB second switch we have assigned for upshifting of gears, and for the third switch we have assigned as downshifting of gears. Now we'll shift gear reverse, gear 1, gear 2, gear 3, gear 4, gear 4. So up to gear 4 we have assigned, and here we are downshifting gear 3, gear 2, gear 1, gear reverse, gear neutral. So this is how we shifting the gears from up shift and down shift. And here the timer is running continuously as the real time clock has RTC. It is responsible for the real time. It is continuously running. So with these complex, what is going to happen whenever any uncertain things occurs or it prone to accident of the vehicle. So with these data storage, the events get stored in the dashboard. So with this black box data, we get to understand at what time or what event or what speed the vehicle have got an uncertain condition or some of the accidents, or we get an idea about what event or what the reason behind the uncertain condition of the vehicle. So we get a quite guess or some better reasons to understand at which position the vehicle got these conditions. So now we enter into the screen or the dashboard by simply clicking here. So it is asking for enter password, as we have given 2424. We enter the same thing, 2424 entered. So we can see the three options: view log. So we'll see the view log. Here are the logs which we have seen here. First one, gear 1, gear reverse, gear neutral, gear 1, and some of the things we can see here. Um, More events right now, and downshifting, fifth event, gear 2, gear 3. So yeah, up to 9 events we can store in the view log. So what next? We'll come back. We'll again enter into our dashboard. So we'll enter the password 2424. Now what we do, we clear the log. We'll just clear the logs. So we just come to the second option and we select RB5 is the select option. We assign it in the code. So logs cleared successfully. We can see here the logs is just cleared successfully. Now what we do, we again view the log by selecting RB5 option. Now we can see here no logs because we just now got cleared all the logs, and from starting onwards we can again start the code, reset it, and we can just enter the data once in 1 minute. So what we are gonna do is, after clearing, so we just again enter the password 2424. Now logs, right, new logs, will select it. What we do is we just clear all the logs 2424. Sorry, wrong password, showing the wrong password. I entered the wrong password. Now again we'll clear correct password 2424. It's the correct password. Now we'll do the clear log option. We just clear the logs cleared successfully. So what we do is again we view the logs. There is no logs here. Now we'll reset it and we'll come again. We do one thing, select the dashboard and enter the password 2424. Now the leftover option is change password. We can change the password too by selecting the option change password. We can enter as per my wish and give 222. We enter the new password 2222. So this is the way the password changed successfully. So this is how the uh, car black box works as per the uh, limited peripherals, we have implemented and executed our project. So this is how the code runs. The display, this is the CLCD where we get the display option, so we can reset it back. And this is all, and these are the LEDs. This is the port D and port B LED, where we can on and off here by using the main switch. And this is the port D, and RBO here is the first RBO on and off. So yeah, LCD you can hear from here, we can uh, on and off the LCD. See, this is how it works. So yeah, this is all about the car black box project. So this is the main working of the project and implementation and demo of the project. So yeah, thank you.